Good day. In this laboratory activity, I work on representing dynamic systems using state space form and converting them into and from transfer function form using MATLAB. On the first part, um, for the part one state space representation, I defined the matrices A, B, C, and D. Uh, and on the F part, I used F is equals to S S A, B, C, and D. And after defining this matrix, this created a continuous time state space model, and MATLAB displayed these dimensions, this one. And this part demonstrates how a dynamic system can be modeled in matrix form using the equations x dot is equals to ax plus bu and y is equals to cx plus du. And on the second part, uh, the second part, the transfer function conversion to state space. I started with the transfer function, which is g of s is equals to 24 s cubed plus 9s squared plus 26s plus 24. And I used or utilized the code ABCD, or ABCD is equals to TF2SS numerator and denominator. This code. And then I converted the transfer function into state space form using the controller canonical structure. And I used the TF of TSS. So I used the code that was provided into the module. And on the third part, which is named given state space model, where x should be equals to the state to the seat number last digit, and in my case that should be 3. And in here I was given a 4 by 4 state space system, and after defining the matrices, I created the state space model and converted it into transfer function form. And then after running this code that I have cleaned and um, created, I expected a result of T of S is equals to 9s squared minus 21s minus 9 all over s cubed minus 10s squared plus 26s minus 12. And factoring that out, that should be 6s, 6s quantity s minus 3.886 and s plus 0.386 all over s, quantity s minus 6, quantity s minus 3.414, and quantity s minus 0.5858. And on this part, I after getting the transfer function in polynomial form, I obtained the factored form, which is the one earlier, and I converted the transfer function back into the state space form using the TF2SS code. And here is the produced canonical form. Okay. And overall, in this laboratory activity, I demonstrated how to represent systems using state space matrices and how to convert them between state space and transfer function forms in MATLAB. And I verified that different realizations, such as canonical and phase variable forms, may have different internal structures, but it produces the same system behavior. And by transforming these models back and forth, I confirmed that the consistency and accuracy of each representation, and overall this activity strengthened my understanding in how a dynamic system works and how it can be modeled and analyzed using different forms, but in equivalent mathematical form. And that is it for this laboratory activity number 3. Again, my name is Nico. Have a good